Yeah, it's started. You can go ahead.
Good evening. Today I, Niyati and Utkarsh are going to present something interesting that we've made on natural language processing, which is a field of machine learning. So imagine you're writing a code and get stuck somewhere, or you want the rest of the code to be written by someone else. That is what exactly GitHub Copilot does for you. It uses artificial intelligence to make writing code easier and quicker. Let's have a look what exactly it is.
The audio is off.
Okay, and so why don't all of us start using GitHub Copilot? There are a few reasons behind it. A, it's not easily accessible to all. B, it's not yet ready for mass usage. And C, it's costly. Hence, we've created our own mini version of GitHub Copilot using a lighter trained model called GPT Neo. Let's have a demo.
Yeah, so I would be presenting the implementation that they have done here. Let me know when my screen is visible.
It's visible.
Yeah, thank you. So what we have done here is have used the GPT Neo with our supercomputer and hosted it on the supercomputer and just calling it here when we are coding. So I like to code in Nano basically because it's very easy to use. Let us take a small example of the avial tree. I believe this is one of the things that we totally don't study in early place. But let's say when we are stuck building it, what we can do is use our plugin that I have set up with Nano. So basically, if you can see below, I can run the command of Copilot and put the file name that is the avial3.cpp here and just enter it, wait for a second or so, and I get the code loaded. Here you can see a partial bit of code because obviously I have not given much information about what really has to be there in ability or not. So let's see another example, and this one with more signs of more positive sign of being running. So you can see I've just given a comment of saying make plots and just declared numpy and plt. So basically what I want the model to do is give an output which actually works with numpy plt and actually make some kind of a plot. The plot is not yeah, specified. So again the same thing, I just run the copilot command as you can see below with the name of the file. I just enter, I just wait for a second or so, I get a code. Now to showcase that this actually works, let me save it and let me run it in Python. So you can see it actually plots something. So obviously this can't be super crazy, else the time to render it will be very high. But for small cases, it works. Now let's take a bit more challenging one, wherein I want to make a tic-tac-toe game. So here I have declared that I have to build a tic-tac-toe game. Player inputs have to be taken sequentially. Score should be maintained, and the board should always update. So there are you can imagine a class and all those functions, all the variables. And I've also set it to use implement AI with Minimax. It's little too much to ask for something that we have trained ourselves on a limited budget and limited resource. So let's try giving it a shot. Hopefully it doesn't take a lot of time to load. But the same command applies copilot tic-tac-toe.java and waiting for a second or so. Yeah, it did output something. It's partial bit of the code, not everything. So here you can see comments from the AI saying ki what each of those functions are doing, what each of the variables are doing, and it actually codes a good amount of part of it. So surely we can't expect the whole of it because that would be way over thousand lines of code, which is quite expensive. So this is what we have built. There are much more examples that Niyati has worked out, hopefully transferring it back to Niyati.
Yes, go ahead. My screen is visible, right?
It's visible.
All right. So I'll be taking on from now. We have created our own mini version of GitHub Copilot with GPT Neo. Let's see how did it happen. GPT-3 is a model trained on 175 billion learnable parameters from huge amount of text, including the entire Wikipedia. How it is different from BERT? BERT requires millions of task-specific examples to pre-tune, whereas GPT-3 performs a new task with just few instructions without fine-tuning. So it has many more examples. Let's go through it. First of all, if we want to create a Java class, we just have to type a basic command, create a Java class, and boom, we get our desired code. Tired of writing header files? Here we go again. If you want to write header file, it will generate all the basic header files for you just by typing a basic command. Stuck with any algorithm? Write a command. If you want factorial of a number, just define its function and it generates the entire code just for you.
Having seen a few examples of our model, now let's see other potential and other spaces where this NLP function can work. First of all, it's chatbot. You can make a chatbot using it. Translation. You give a few examples of English to Chinese, Chinese which is another language. You give a few examples and you get a millions of other translations. But then there's language generation and there's question answering. I hope you like it. Thank you.
Thank you.
Yeah, thank you all for your time. This was the presentation and work done by them. We wanted to keep it very quick just to showcase what they have done and show that we could appreciate them. That was the motive of the call. People can leave now. Thank you for staying.